Hi. Hi everyone, I am Narendra, PGT Physical Science from LRT. Let us see parallel combination of resistors. Now, we have taken three resistances which are connected in parallel combination. When we can say they are connected in parallel combination you can see that, for example, positive of first resistance, positive of second resistance, positive of third resistance, if they are connected to single common point, then we can say that it is a parallel combination. All the negatives of R1, R2, R3 are connected to a common point, then I can say that this is a parallel combination. What is the difference between series and parallel? In series, there is only one flow of charges, but in parallel combination, there are multiple ways to complete a circuit. For example, if R1 is not working, then current can flow through R2 and R3 and can reach the negative terminal. If R2 is not working, and current can pass through R1 and R3 and reach the negative terminal. So in that way there are three ways to complete the electric circuit. That's why parallel combination is more preferred. Now let us see what is the total effective resistance whenever we connect three resistance in parallel combination. Let us see by applying Ohm's law, resistance R1 at R1 by applying Ohm's law, the amount of current I1 is equal to V by R1. In the same way, applying Ohm's law to second resistance I2 is equal to V by R2. By applying Ohm's law to third resistance I3 is equal to V by R3. In parallel combination you will observe one common thing, that is potential difference remains constant. Now total current, that is nothing but I value is equal to V by R into R, V by R of equivalent resistance. Now let us see. We have observed one thing, that in series combination the value of total potential difference is equal to sum of individual potential differences. But here the value of total electric current will be equal to sum of individual electric currents. So total current inside this circuit is equal to I1, that is current across first resistance, current across I2, current across second resistance, I3, current across third resistance. So I is equal to I1 plus I2 plus I3. Now let us substitute the values of I1, I2, I3 and I in this equation. When we substitute all of this equation, you can see V by R equivalent resistance is equal to V by R1 plus V by R2 plus V by R3. By taking V common and by cancelling it, you get a value, that is reciprocal of equivalent resistance in parallel combination is equal to sum of reciprocal of individual resistance. So here in this one we will get 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now to understand this more effectively, let us take small example. In this one I have taken, let us take first resistance value is 10 ohms, second resistance is 20 ohm, third resistance is 30 ohm. By substituting the values in R1, R2 and R3, here you can see you will get 1 by R equivalent is equal to 11 by 60. And by taking the reciprocal of R equivalent resistance, you can see 60 by 11 is equal to 5.5 ohms. Now we can understand clearly that by connecting resistance in parallel combination, equivalent resistance has decreased, and as you can see it's not 10, 20 or 30, it is less than that. So from this we can understand that whenever we connect resistances in parallel combination, we observe that effective resistance value decreases. But in series combination, whenever the resistance are connected in series combination, the total resistance value always increases. By using these applications only, by other circuits are developed like ICs in computers, and we are using this type of combinations, series and parallel combination basing on their connectivity, and we are using it. So in the next class, let us continue about Kirchhoff's laws. Thank you.